Hey everyone, and welcome to the Context Minute. Today, we are diving into the Rust programming language. You've probably heard the name buzzing around, and for good reason. It's famous for being incredibly fast, super reliable, and just a joy to work with. So let's get into it and see why people are calling it a total game changer.
Okay, just to kick things off, get a load of this. For several years running, actual developers, the people in the trenches writing code every day, have voted Rust their #1 most admired language. That's not a fluke. When you see that kind of consistent praise, you know something special is going on, and we're about to find out exactly what that is.
All right, here's our game plan. We'll start with why it's so admired, then dig into a classic problem that's frustrated programmers for ages. We'll uncover Rust's unique superpower, see where it's being used in the real world, and then wrap up by looking at why it's growing so incredibly fast.
So first up, the most admired language. To really get why developers love this thing, we've got to go back and look at its origin story.
So Rust actually started as a personal project by a Mozilla developer named Graydon Hoare. Mozilla saw the potential and started sponsoring it back in 2009. By 2011, it hit a huge milestone. The compiler could compile itself, which is a big deal in language development. Then, in 2015, the world got Rust 1.0, the first stable version. The whole point from day one was to tackle the security flaws and memory bugs that were so common in other languages.
Now, to really appreciate Rust, you have to understand a fundamental problem that's been around in software development for decades. I'm talking about the great trade-off.
For the longest time, developers had to make an impossible choice. On one side, you've got languages like C++, which are absolute performance beasts. They're incredibly fast and give you precise control. The downside? That power comes with risk. It's easier to make critical memory errors that lead to crashes or security holes. On the other side, you've got languages like Python. They're much safer because they manage memory for you automatically. The catch? They're slower. So you always had to ask yourself, do I want speed or do I want safety? You couldn't have both.
And this is where Rust just walks onto the stage and changes everything. It was designed from the ground up to solve this exact problem. It offers a truly unique superpower. All the memory safety you could want, but with zero performance cost.
The secret sauce here is a concept called ownership. And the most important words on this slide are checked at compile time. See, other safe languages use a garbage collector that runs in the background, cleaning up memory, which slows the program down. Rust does it differently. It enforces all its memory rules before the program even runs. It's like having a super strict editor that finds all the potential problems ahead of time so you don't need a slow cleanup crew later. Here's a great way to think about it. The warehouse analogy. Imagine your computer's memory is a massive, perfectly organized warehouse. Every piece of data is a box. In Rust's warehouse, every single box has one and only one official owner. Now, you can let someone else borrow a box, but there are very strict rules about how and when it gets returned. Because every item is tracked so precisely, you just don't need that slow cleanup crew. The whole warehouse just runs at peak efficiency.
Now, this isn't just some cool academic theory. This unique strength is why major companies are using Rust to build some of their most critical systems. Let's take a look at where it's being put to work.
Rust is trusted for the heavy-duty stuff, the kind of code that absolutely cannot fail. We're talking about the guts of operating systems, device drivers, and core components of web browsers like Firefox. It's also used to build lightning-fast web servers and network services. And it's perfect for embedded systems, the brains inside smart devices and robotics, where efficiency and reliability are everything.
And just look at the who's who of tech betting on Rust. Amazon uses it for key parts of AWS. Microsoft is rewriting core components of Windows and Rust to eliminate security vulnerabilities. Meta, Cloudflare, Dropbox, they all rely on it for their high-performance systems. When these companies trust a language with their infrastructure, you know it's the real deal. So let's pull this all together. What are the core advantages that are fueling Rust's incredible growth? It really boils down to three main pillars. First, performance. It's as fast as C and C++, period. Second, safety. The ownership system literally eliminates entire classes of bugs before your code even runs. And third, concurrency. That's just a way of saying your program can do many things at once. This is notoriously difficult to get right, but Rust's rules make it so much safer that developers actually call it fearless concurrency. And one last killer feature is something called zero-cost abstractions. It sounds complicated, but it just means you can write clean, high-level, easy-to-read code, and it compiles down into machine code that's just as fast as if you'd written it the hard way. You really get the best of both worlds, productivity and raw speed.
So ultimately, that's what this is all about. Rust is rewriting the rules of programming. It proves that the old trade-off is dead. With Rust, developers no longer have to choose between fast software and safe software. They can finally and confidently have both.
And that's our look at the Rust programming language. Thank you so much for joining us on the Context Minute.